Let's take a journey to a place no human can ever go, the very center of our planet. This is, and I love this, an incredible scientific detective story. It's all about how we figured out how to peer thousands of kilometers beneath our feet without ever actually leaving the surface. How cool is that? I mean, it's a pretty fundamental question, right? We're all just living on this thin, rocky shell. So, what's actually underneath? For most of human history, it was a total mystery. So how on earth did scientists finally crack the case? Okay, first, let's just try to wrap our heads around the scale here. We're talking 6,378 kilometers. That is the distance from the surface, where we are, straight down to the center. To put that into perspective for you, that's like stacking over 700 Mount Everest one on top of the other. It's a mind-boggling depth.
Now, contrast that massive number with this one. 12 kilometers. That's it. That's the deepest hole humanity has ever managed to drill. We've barely, and I mean barely, scratched the surface. We're not even talking 1% of the way to the core. It's less than 0.2%. So this really shows you the fundamental challenge, right? We simply cannot go there and look.
So, that brings us to the first part of our investigation. How do you explore Earth's unreachable interior? Well, since physical exploration is totally off the table, scientists had to get really clever. They basically became detectives, piecing together clues that they gathered right here on the surface.
Yeah, so the crucial point is this. We have to rely on evidence that travels up to us. We need to find ways to see using something other than light. Things like physical samples that get blasted up from deep below, or even the subtle vibrations that ripple through the entire planet.
So, where did these scientists start their investigation? Well, before they had their main breakthrough, they just began by gathering every single clue they could find right here on the surface. And these clues, they pretty much fell into two main categories.
So on one hand, you had direct sources, physical stuff they could actually hold and analyze. And then on the other, you had indirect sources, which required them to make some pretty clever inferences from things like gravity and magnetism. Each one provided a small piece of this giant puzzle.
Okay, so the direct clues are the most straightforward, right? We've got rocks from super deep mines, like the ones in South Africa that go down 3 or 4 kilometers. And then, a little more dramatically, we have magma from volcanic eruptions. Think about it. This molten rock is literally a messenger from the deep, giving us a physical sample of the mantle, even if we're not totally sure the exact depth it came from.
Then you have the indirect clues. For instance, we know from mining that temperature and pressure go way up the deeper you go. We can also study meteors, which are basically leftovers from when our solar system was forming. And since Earth was made from the same stuff, the dense iron and nickel we find in meteors, well, that's a pretty strong hint that our own core is made of similar material. But look, all these clues were just scattered pieces of a massive puzzle. They were helpful, for sure, but they couldn't give us a clear map of the interior. No way. To truly see the whole picture, scientists needed a way to scan the entire planet all at once. And that breakthrough, it didn't come from digging. It came from listening. And that right there brings us to the single most important tool in this entire story, seismology. By studying the waves generated by earthquakes, scientists found a way to do something amazing. It's kind of like a planetary-scale ultrasound, revealing all the structures hidden deep inside.
So what is an earthquake, really? Well, it's just a sudden, massive release of energy when rocks break along a fault. That energy explodes outwards in all directions, sending these powerful waves traveling right through the entire body of the Earth.
Okay, so earthquakes produce two main types of waves that travel through the planet. First, you've got P waves, or primary waves. Think of them like sound waves. They can travel through solids, liquids, and gases. No problem. But then there are the S waves, or secondary waves. And this right here is the crucial clue. S waves can only travel through solids. They get completely stopped by liquid. Remember that fact? It is the key to this whole mystery.
So, after an earthquake happens, seismographs all over the world start picking up these waves. And by tracking their arrival times and their paths, we can start to map the interior. But scientists noticed something really strange. For any given earthquake, there are these huge areas on the other side of the planet where some of the waves just, poof, never arrived.
This area of silence has a name. It's called the shadow zone. Now the P waves, they get bent by the core, and that creates a small shadow. But the S waves? Oh, that was a completely different story. They created a massive shadow zone that covered nearly half the planet's surface.
So this became the million-dollar question. The P waves, okay, they were bent, but they still made it to the other side. But the S waves would travel down into the Earth and then, gone, they'd just vanish. So what could possibly be down there that would stop them dead in their tracks?
Well, the answer to that question revealed the fundamental structure of our entire world. By solving the mystery of the shadow zone, we finally got to see the layered interior of the Earth for the very first time. And here it is. The reason the S waves disappear? It's because they hit a massive sphere of liquid metal deep in the Earth's center. Remember how S waves can't travel through liquid? Well, this layer casts an enormous shadow on the opposite side of the planet. This single discovery proved it. The Earth has a liquid outer core.
So, this is the complete picture that finally emerged. Using the behavior of both P and S waves, scientists mapped out all the layers. You've got a thin outer crust, a huge rocky mantle, that liquid outer core of iron and nickel, and then, get this, the final twist, a solid inner core right at the very center, literally squeezed back into a solid by the immense pressure. So let's just do a quick recap of the layers, right? We live on the solid crust. Below that, you've got the mostly solid mantle, which has a weaker, kind of molten layer that's the source of all our magma. Then you go down about 2,900 kilometers and bam, you hit the liquid outer core that stops those S waves. And finally, right at the very center, the pressure is just so insane that it forces the inner core back into a solid state, even though it's hotter than the surface of the sun. Wow.
So you might be thinking, okay, cool, but why does any of this matter? Well, because this internal structure isn't just a diagram in a textbook. The processes happening thousands of kilometers down literally create the world we live on. Everything from the ground beneath our feet to the protective shield above our heads.
Let's just take volcanoes, for example. Heat from the core drives all this movement in the mantle. This whole process melts rock in that weaker layer I mentioned, and that creates magma. Well, that magma can then find its way to the surface in a volcanic eruption. See? It's a direct chain of events connecting the deep interior to the world we can actually see.
And that liquid outer core, it does way more than just stop waves. The churning, flowing liquid metal acts like a giant dynamo, and that's what generates Earth's magnetic field. This invisible shield protects our entire planet from harmful solar radiation, and it's one of the key reasons life is even possible on the surface. And of course, the immense forces deep within the Earth are also responsible for things like earthquakes, and devastating events like the 2004 tsunami are just a tragic reminder of the incredible power that's always lurking just below us. So just by solving a simple mystery, hey, where did those waves go? We uncovered the entire hidden structure of our planet. I mean, it's an absolutely incredible testament to scientific ingenuity. And it really makes you wonder, doesn't it? If we can map a world we can never, ever visit, what other unseen worlds are we going to reveal next?